Here we go. Bonsai. Eye of the tiger.
What can you do?
Welcome to the Hackaday podcast. I'm Elliot Williams, editor-in-chief of Hackaday.
And I'm Tom Nardi, managing editor.
This is episode 152. Today we'll take you on a 555 timer extravaganza, look at EMF chip glitching 3 ways, a magnetic mechanical keyboard, and the best tricorder ever. Let's see, first item of news this week is the SGX deprecation prevents PC playback of 4K Blu-ray discs. And basically, this is a change in Intel chip hardware that was necessary for hardware Blu-ray decoding, or rather to run the DRM that was required to decode some Blu-ray discs. And now it looks like, who knows how far into the future, you won't be able to play these.
I looked at the article on this one. There's no like end date. I thought it would end and say, and this is what's happening. Like, no, it just seems like we can't do this anymore, and you have to deal with it. The kind of conclusion in the article was like, oh well, all we have to do now is get non-DRM 4K Blu-rays, and it'll be fine. Like, all right, fine, yeah, sure. Like, that's not really a solution because obviously they're gonna put DRM on movies, so. And, this sucks for, admittedly a small portion of the entertainment consuming world, right? Because, sure, everything's moved over to streaming. Yep. We're on Netflix, Amazon Prime, whatever. But there are definitely people who said, hey, I don't like that. I don't like not owning my content. I don't like the fact that you could take a movie away from a service. So I'm going to, I'll show you. I'm going to buy all my movies on physical copies. Well, little did they realize that, at some point in the future, their computer might actually be able to play those discs. And granted, you still got, dedicated Blu-ray players and all that, but there are certainly some people who are very bummed out about this right now, especially if you wanted to rip the Blu-rays to a digital file and, put them on like your own file server or something. That's going to become a lot harder with these new machines. And I think even AMD had similar problems. I think it was in there.
That's what it said.
Yeah, so it's Intel for now, but it doesn't seem like be too much to expect. AMD might be following suit now that the Band-Aid's been pulled off. So you might have to keep an old computer around just to rip your Blu-rays, which is unfortunate. Let's put it that way.
I don't know that this is a particularly controversial hot take, but DRM sucks.
Yeah. Well, and in the comments, that was the takeaway, really. It wasn't so much that, like, think? Intel sucks or Blu-ray sucks. It was like, just DRM sucks.
DRM in general sucks.
Right. If you didn't have the DRM, it'd be fine,
That's correct.
But we do. And that's the reality of where we live, right? So I guess the rationale was there were some security issues, too, with the DRM. Like, I guess that's how Intel's getting around this. They're saying, hey, it's a liability to keep this feature on, which is, a whole other story. And like, as often the case, the people getting punished are the ones who are playing by the rules. They went out and they bought their legit Blu-rays and they thought everything was fine and they're burned. Whereas if you had just, grabbed a torrent and downloaded it, you wouldn't have to worry about this. So
DRM sucks.
It's very unfortunate.
Well, let's switch up to something pleasant instead, and that is that the winners of the 555 timer contest have just been announced. And I love the way the 555 timer is like a super minimal chip, and the way that pressure to do something with super minimal chips makes everyone come out with their full creativity on. The contest this year got a ton of great submissions. I think there were 78 in total, of which a full 10 or 20 should have won a prize. And that's kind of a bummer that we only have 3, but we do have 3 $150 gift certificates to DigiKey. Thanks, DigiKey, for sponsoring this contest, by the way. The winners include the Giant 555 timer, Menorah 555, and Cyclotone, the mechanical punk console sequencer. It's funny, all of our judges picked Giant 555 timer in their top 4, and a couple people had it as their top 1. It was the overwhelming crowd favorite. And so then I started reading Rudraksha's write-up, and it is a wooden 555 timer, except inside is an old school breadboard made of completely discrete components. Well, each of the component pieces is assembled separately on its own piece of wood, and then they're wired all together and put inside this thing. The two comparators are on like triangle shaped things that look like their circuit diagram and et cetera, et cetera. It's really a fantastic build. It's a circuit sculpture. It's an old school breadboard with like nails and tacks and the parts soldered to them. I think a good number of the parts are reused, but the beauty of following the schematic, laying out the different schematic parts on individual subparts that are actually made out of wood and then wiring them all together. The 555 timer is like 50 years old right now, and this is like your heirloom 555 timer.
I think everybody voted for this one because we all want this one, right? Like, we'd all love to have this
Damn straight.
around. Yeah, it's like a conversation piece, if not like an actual educational aid.
And it absolutely fulfilled its mission, which is, Rudraksha says, this project made me learn what current mirrors, constant current sources, sinks, long-tailed pairs, output stages, flip-flops. He learned all of this kind of both analog electronics and digital electronics, all to put this circuit together. And I think that alone, the process of doing this 1 bit by 1 bit and testing each of the sub modules and putting that all together is also fantastic. So like, we gained something by looking at it, but I don't think we gained half as much as Rudraksha did by making it.
My favorite part of the whole write-up is towards the end where he has alligator clips on all the pins that hook up to a breadboard to show that, like, yes, it works. Like, you can hook, you can drop it in, any kind of 555 circuit. Like, it's not just for show. Even the pins themselves are functional. Really cool.
But there's no end of awesome 555 hacks here. The second up Menorah 555 is stunningly clever. The cyclotone is just noisy, crazy, and interesting. We also had a bunch of honorable mention categories. One of the projects had a 555 timer radio running at 4 megahertz. That won the bandwidth buster honorable mention category. There were a couple in art. I won't spoil those for you. There was a shouldn't have done that with a 555 timer category. And in those were dumping firmware, which a 555, which we'll hear about soon.
I was going to say, shh, not too much, not too much.
Oh. And also a DMX lighting console. This is bit banging a serial protocol using the delays in the 555 timers. There was art galore, and the craziest, and this I had to make up an honorable mention category. This is the WTF award to Adrian Freed, who had his own 20-pin dip 555 plus sine wave generator ICs manufactured.
Ooh.
And used them in this contest. So, like, kudos to you for getting the old masks and making your own ICs. That is insane, and thank you very much. I'm going to have to dig deeper into that project. I don't think there were quite enough details in the write-up that everyone reading it fully understand that these were custom ICs. But, yeah.
I think the big question now is, it was 10 years ran the last 555 contest. Do you think we'll do the next one a little sooner?
I hope so.
Although maybe they needed the 10 years to come up with all the cool ideas.
This is a journey into sound.
What's that sound?
What's that sound?
And that brings us to this week's What's That Sound? A couple weeks ago was a sewing machine. This week I've gone in a totally different direction. It's a synthesizer, and it's bleepy bloopy synthesizer. And the question for all of you out there is, what exactly is it?
I can't even hazard a guess. It is the noise of electronic components.
Correct.
I will. Put me down for that.
Tom Nardi, noise of electronic. Check. If you think you've got a better guess than Tom, fill out our form. You'll find it at hackaday.com/podcast. Enter the handle that you'd like to be called on the air and your t-shirt size. And we'll select from the correct answers, roll the magic dice, and the winner gets a Hackaday podcast t-shirt. My first hack this week comes from serial awesome standalone synthesizer maker Eric Brandal, and this one is the eerie sounds of Ioalialia. I did that wrong for sure.
In this video, I will go through all the various phases of work involved in building my latest project, Ioalialia.
An ESP32 valve analog hybrid circuit sculpture. And that is basically what this is. I was trying to think about, what is this device? Is it analog? No. Is it digital? Yeah, parts of it, but no. Is it solid state? Some of it. Is it vacuum tube? Yes, also. And in the driver's seat of the whole thing is an ESP32. So it's not only all of that, it's also Wi-Fi connected, and it's got some sweet blinking lights to boot. It's a beautiful piece of circuit sculpture, but it's also a nice kind of minimalistic acrylic box that houses the speaker. And then this kind of circuit sculpture cascades down the side. The sculpture itself is really nicely made. He has a making of video that you should definitely go watch if you're interested in this sort of thing. He talks about his strategy for using the essentially bus wires that go up the side and how he then connects all of the different parts of the circuit to it. And parts there are, it's driven by square waves that come out of the ESP32, but then they're filtered by an analog filter. And to navigate between the kind of digital and analog world, he's got a digital potentiometer in there that like turns the pot on this filter circuit, because this circuit is a really old one. It's a reproduction chip of the CEM3320 filter chip, which was the filter in the old Oberheim synthesizers. Again, if you're a super huge synthesizer nerd, you will know that they had the most like buttery 12 dB filters in them. The old Oberheim filter sound is kind of its own thing, and this inherits a lot of that by using that actual chip, but it pairs it with digital control by using a digipod in the middle, which is awesome. It runs through a tube amplifier, and then it also runs through a Princeton Tech PT2399 reverb chip. So it's got everything in there, and it makes programmatic music that's determined by whatever he uploads to the ESP32 over Wi-Fi. That's pretty awesome.
I'm not. What'd you say? A sequencer freak? I don't know if I'm enough a sequencer freak to appreciate all the details, but it is beautiful. I did love the mix of components on here. For the circuit sculpture stuff, it tends to be, a lot of designs tend to be kind of simplistic, but this is a lot of parts to put in to a circuit sculpture. So my hat's off there. And like the little caption picture says, like, just incredibly straight lines. Like it's just beautiful to look at, even if it didn't make any noise or do anything. It's kind of thing where I would have it just on the shelf just to look at it.
And he's got some really great tricks. You should watch the video because it is a nice how I made it. And it includes kind of his tricks, like he sets up a bunch of pin headers. They look like they've got the 0.1 inch raster on them, and he lines up his different bus lines by putting them in the gaps on those and soldering them down. So he's got some really clever tricks that you can follow and totally cheat on if you have to make one of these yourself. The breadboard at the beginning of the video, he actually tested the whole circuit out, of course, like you do, on a breadboard before committing it to this much more difficult format of the circuit sculpture. The point here is the synthesizer, and whether you think it sounds neat or not, it's just such a cool mix of all of these different technologies that I had to love it. And it reminded me of some other things that we'd run on Hackaday, and I went back and looked at them. And of course, they're done by the same guy. This Eric Brandal has done a number of cool synthesizer art installations. In fact, another one with an ESP32, I'll throw the links in the show notes. ESP32 is the brains behind this art installation, is really cool. There he's got kind of full standing analog synthesizers that are driven by the ESP32. Whereas in this one, the ESP is actually kind of making the square waves that end up being the sound. So the weird hybrid nature of this current one just appeals to me even more, if you can believe that.
Well, this is one that I am particularly excited about, and that is finally the release of Riskable's Void Switch design. The idea here is to create a 3D printable switch, and when I say switch, I mean like a keyboard switch. Think a replacement for like the Cherry MX, the classic switch. If you could just 3D print one, that'd be cool right off the bat. But more than that, there's no springs, there's no contacts of any kind, and every element in terms of stuff like linear travel and the force required to push it is customizable through an open SCAD script. And the magic here is that it uses opposing magnets to develop the resistance. And by controlling how far apart they are and how thick the plastic is between them, you can dial that in for a specific value. So you might be wondering, though, okay, fine, that's a switch and it's got magnets and I have a little fidget toy, but how do you get that into a keyboard? The trick is to put each one on top of a Hall effect sensor, which can then detect the changing magnetic fields. So the beauty of it is that you can have all these switches lined up, sitting on top of a PCB with no physical connection. And, Riskable does a demo video earlier. It takes the whole top of the keyboard off and puts it in the sink and washes it like it's a plate, because there's nothing electronic inside there to get damaged. And then you can just shake it out and drop it back on top of the PCB, and it just, senses all the keys. The big goal here is for like a completely customized ultimate keyboard, right? You could say how much force you want each key to be, all that kind of stuff. But, I also see a lot of potential for, say, putting switches in areas where like corrosion would be a problem. Talk about like a marine environment or something where you could have this magnetic switch on the outside of your enclosure and the sensors inside read the positioning. I mean, it's a really clever idea. I would say, and this is just me, I do not represent Hackaday legally, but I think it's one of the most inventive and original ideas that's come across in a while. I mean, it takes what you figure is like a completely solved idea, right? Like the keyboard solved. We know how the keyboard works, and it totally reinvents it. And the best part is it's all open. It's phenomenally documented. Riskable himself is a really cool guy. He loves talking about this stuff. If you have questions, and I actually got in contact with him, and then he sat through my very silly questions about printing them and that kind of stuff. And I really, really am excited to see what the community can do with this. I mean, already it was a huge hit. We got a lot of comments, a lot of views. I've talked to him since. He said he's been getting a lot of attention about it because it's making the rounds now, as it does. It's real weird, right? Story comes up on Hackaday, and all of a sudden, 10 other sites write about it, and it's just really well deserved. It's a phenomenal design. Once I can dial in all the little fiddly bits, I intend on printing a couple of them myself. Yeah, I mean, this is the way, right? Like coming up with cool ideas, making them open source, and just seeing what the community can come up with.
So what's interesting about this to me is that it splits the electronics from the mechanics.
Right.
All the electronics are entirely self-contained and are all on the PCB. All the mechanics are in this 3D printed /magnet part that sits above it. And if you don't like the way it feels, you can switch out the mechanics part and you don't have to change anything on the wiring on the PCB. I made my own keyboard. I type on a custom-made keyboard all the time. It's not exactly the way I'd like it, and I can't change any of it without pulling all those things out, desoldering them. Like, they're all hand point-to-point soldered by me, so it was already kind of sketchy to get it together. It's just going to be sketchier if I have to take it apart and resolder it. Like, that's a pain in the butt. Whereas he could just pull this out, swap it out, done.
Yeah, I absolutely see potential for this beyond the traditional keyboard and macro pad. I mean, you could definitely add a couple of these to any kind of project. I think I forgot to mention, because you're using a Hall effect sensor, they're analog too. So
In
you can
principle.
actually, in principle, right, at least in theory, you can actually detect how hard you're pushing it. He does talk about using a reed switch too if you just want like that traditional on and off thing. It starts getting tricky because, the keyboard driver and what it presents to the operating system and stuff. But, there was talk about using, you push the button harder and your character moves faster in games and stuff like that. I mean, there's a lot of really interesting things that this makes possible. I wouldn't be surprised if we see somebody like Razer or something down the line, some of these, PC manufacturers saying, oh, I like this idea. I might do this too. This is mine now.
Somebody came up with an analog key switch thing. I think it used light. I think it was LEDs and photo sensors or something, right?
Yeah, and I'm pretty sure we got a story on. Well, we can put that in the notes too.
I think we must have covered it when it was new. But then the question was, what the heck can we do with this, right? It's like now we have to write drivers to support this extra degree of freedom per key on a keyboard. How are we going to handle that? And I think, despite what you might think that might be cool for like press W down just a little bit and you sneak, you jam W all the way down and you run. Like there are definitely possible interactions there that could be cool. I think that really never went anywhere, which is kind of a bummer. But on the other hand, how much coordination would it take to separately manipulate multiple keys in this kind of analog fashion all at once? I think that'll prove to be too difficult for the people involved rather than for the machine. But
I like how somebody in the comments chimed in and said like the Apple III had multi-stage keys like that could do something similar. Like the harder you pushed the cursor keys, the farther it would go or something. So they tried this back in the day, but it didn't really catch on.
Well, I hope that this does catch on, and I hope we see these not just in random little keyboards, but in the same idea in projects everywhere.
Absolutely. And she might get mad at me, but I was told, a little bird told me, that Christina may be attempting to build a full keyboard of these. It's a lot. It's a lot to print.
That's a lot of work.
It's a lot to print. And, we were kind of going back and forth a few days ago, and I was like, I'm willing to, print some of the ones here and mail them to you. Maybe we can tackle it like in parallel. Because I'd really love to see her be able to build out the whole thing. And if there's anyone that can give us all the possible information we could ever hope to have about a keyboard, it is Christina. So she's the one that I nominate for the review.
My next hack is giant 3D prints piece by piece. This is a research paper by Niels Koenig, Adrian Koenig, and Ferdinand Schockenhoff, all of them from TU Munich. Go Munich. This trio has developed a process for attaching together flat or basically flat 3D prints with each other to make an even bigger surface. And the application here is in printing out test interiors for a car. And so they need something basically like you could thermoform if you had a super gigantic thermoformer, but they instead are approaching it by 3D printing all of the individual parts and joining them together. The part of this paper that I thought was brilliant was the realization that there is a problem here, and that is that nobody likes to have to split a 3D print into a bunch of different pieces, and yet it's one of those things that we all have to do, either because of print orientation or because of size or because of, I think that's it, just print orientation or size.
Those are plenty good reasons, though.
Those are the two, though, right? And it's something that we all avoid doing because it's painful. And there are things like registering the pieces together. If you're going to glue them, especially if you're using super glue, that's a tense moment when you're trying to get the two pieces aligned just so. So one clever thing you can do is print I always use square and kind of tapering cones, like almost pyramids, but flat top pyramids, to align parts together when I have to print them. But this is something that I add manually to the parts. Like I'll cut it in half and I'll add these positive negative parts. the point here is this is all computer-generated models. The computer should be doing this for us. We just need to think of the right way to do it and write the code to have them do it for us. And here they're doing it with flat sheets, so none of the traditional like pegs can work. They end up coming up with this clever like fold over lip and pass under, and then there's a pin that you drive through it to link it together. It's called a joggle, a joint made with a rabbit and a tongue together. But you should read the paper. It really goes through all of the kind of engineering constraints that they had in mind on this joint. That is, it has to look seamless. It can't wiggle or pull apart, which is where the pin comes in play. And it has to be self-aligning, which is where the joggle comes into play. And it has to print nicely. That is, none of the additional parts that they're adding to this can make it harder to print. And so this is the solution they come up with. And it looks really awesome. And it looks like a great system for making flat pieces. I think we need to think about systematizing how we connect all sorts of 3D print pieces together. Square ones, blocky ones, thin ones, tall ones. And there needs to be, like, if I'm doing my work in OpenSCAD, for instance, there needs to be an OpenSCAD library with all of the different ways of slicing and joining pieces so that I don't have to think about it every time.
I personally hate printing big things. It always stresses me out, whether it's going to pull off the bed or it's going to take too long. I'm kind of a coward. When I see much more than like 10 hours on the estimated print time, I'm like, oh, no. I gotta cut something in half. I got to make it 2 pieces. So this is definitely a problem you run into all the time. I think this solution here is a little bit of a one-trick pony for the kind of thing they're doing.
It only works for essentially flat surfaces, right? Like if you're joining 2 plates together, this is a clever way to do it.
Yeah. But yeah, like you said, I mean, this is kind of the foot in the door maybe for coming up with some kind of a way to automate it or at least make it easier. Not that the cutting them in pieces is hard, right? You could do that simple, but adding some kind of alignment mechanisms, whether it's a printed feature or even I've seen just putting holes in both sides, and then using dowels or something.
Sure.
I'd even take that as an automatic thing to save me from having to go in there into the model and doing it.
And some people do it by using printer filament because that's a dowel you've got on hand, right? So you just put a 1.75 or slightly bigger hole in each piece at the same place, and then you just put a piece of filament through there, and that's pretty clever.
Some kind of a slicer plug-in that'll pop those little 1.75 holes in it and say, hey guy, now just break off a little piece of filament and stick it in there. If not for strength, at least for the alignment, when you're setting the parts together.
I guess their particular need for strength here comes from the fact that they're using essentially flat plates joined end to end because they don't have much of a gluing surface there.
Right.
Whereas if I'm taking 2 blobby sized things, 2 squares and trying to glue them together, you've got a big gluing surface area in common. So there maybe all you do need is registration.
Yeah.
But I definitely agree with them that this is the sort of thing that we should have a standard procedure for because it's a problem that you run into all the time. And even more so if you weren't afraid of doing it, if it wasn't an inconvenience to cut and glue things together, you might do it where the benefits of doing so are kind of minor, but would be totally worth it if it were easier. Like I'm thinking of avoiding overhangs and stuff, or printing it so that the long way of the noodle, so that the grain of the plastic noodles is in the strength direction that you need.
Well, despite trying and failing to make a Star Wars blaster for the last couple days, I am actually more of a Star Trek fan, which is why I gravitated towards this one. I mean, I wrote it up too, so I figured might as well talk about it on the podcast.
Heck yeah.
This is Mangy Dog's Voyager tricorder. And now you got to say that with a kind of a star on there because when Voyager was in the concept phase, they did all this concept art, and they said, okay, well, the crew's going to have new tricorders. Well, when it comes time to make the show and actually pay somebody to do these props, that becomes a problem. And they said, hey, remember that show Star Trek The Next Generation? Just take their props. That show's done. They're not using them anymore. In the end, the show used the hand-me-downs from Picard. But Mangy Dog was always just fascinated with this concept for a visually evolved tricorder, and he said, well, I'll just make it myself. So in 2019, he made one, and it was gorgeous. So much so that other people were like, well, why don't you make me a couple of them gorgeous tricorders?
Mm-hmm.
As happens, right? We get these, people say, hey, can you make one more? Can you make two more? Can you make three more? But here's where the story gets tricky. So he takes a couple commission orders and says, hey, no problem. I already did this. I know exactly what to do, what to buy. I'll get it to you in a couple months or whatever. So he buys what he believes to be the same components, only to find that in the time since he built the first one, something's happened. Suppliers changed. Specifically, the issue was the screen. The original one he bought was gorgeous, and, he has a video. You can see it from all angles. It looks phenomenal. The new one's faded. The colors weren't right. Long story short, he had to get a new display, and that meant a new chip to drive it. And then he said, well, if I'm doing that, I might as well revisit the whole PCB. And then, I'm thinking maybe I'll use my resin printer for more of the parts, and it turns into a whole new build.
Maybe I'll just entirely redo everything from scratch.
And that's kind of the name of the game on this one is, if you held them both next to each other, and he does in the video, you would say, oh wow, they're quite similar. But he flips them over, opens them up, and it's a completely different build. And it's just really cool to kind of follow along. And I say follow along, like literally follow along. He's done 3 videos to date. There might be more in the wings. I don't know. Very long videos that he just kind of walks you through everything. So you really get to see all the details, software and hardware. And, it's full of little interesting tips like, when he was messing around with his first generation one, he drops it and he breaks the thing in half. And he goes, well, I guess the hinges weren't strong enough. Like that was the take. Like, he had a good sense of, good spirit about it. He wasn't like, distraught. I'm sure he was distraught, but
cried for hours.
His biggest takeaway was like, well, I guess I got to redesign the hinges. And he decided that 3D printed ones weren't working. He goes to brass, but he has to hide wires in the hinges, right? Because the bottom, bottom has electronics. Incidentally, on the real show, there was like a wire going out of the back of the thing into the actor's sleeve. Like they didn't even attempt to do that kind of thing. Like this is so much more advanced than anything they had when they were actually making the shows. So he's got to hide the wires in the hinges. And originally, I guess he was running a bunch of wires, and it kind of, it dawns on him like, wait a minute, if I do like, some serial communication between the board in the bottom and the board in the top, I can cut that down to just power and, RX and TX. So then he goes, well, I guess I got to redesign that too. So like, so all these little things ended up to be a complete redesign, and it's, not everybody's making museum quality tricorder props in their houses, but I think we've all had a project or two where like little things added up into that point where you're just like, you know what? I'm going to start from scratch. And in the end, it's better for it because, the new design, he says easier to manufacture. He's happier with this one. I think there's a third one he's talking about, too. So, evolution can be painful, but the end result is often worth the journey. We were talking about this on the Discord server, which incidentally we have, and you should join. And I made the mistake of asking him like, hey, it looks so beautiful and it's so advanced. Like, why don't you put some real sensors in there? And then just code, I was like, yeah, it'll be easy. Just hang some sensors on the I2C and write some code. And he was just like, no. He was like, no, it is not easy. And then he sent like cutaway views of stuff where like there is no room inside. Like, everything is so tight. There is a place for everything, and it's all like there's not just like a little area in there where you could toss a couple sensors. Like this thing is built for a purpose, and the purpose is looking cool.
Right.
Anything more than that is going to be a whole new design, and he's not ready for that yet.
My next hack is glitch your way to reverse engineering glory with the Pico EMP. This is an open source project by Colin O'Flynn, and if you've heard this name before, He is the originator of the Chip Whisperer, which actually took second place in the first Hackaday prize way back in 2014, if you can believe that. The Chip Shouter, on the other hand, is an EMP tool. It basically tries to zap the chips in question and glitch them over, a part of their unlocking routine. This now is the Pico EMP. It's a small version of the Chip Shouter. It's a reasonably high voltage EMP pulsar. And this one is completely open source and you can make it yourself. Colin has taken a lot of effort to make this design safe for you to get manufactured, which is nice. But he also mentions that you're still totally on your own here. You're dealing with a handheld device that puts out a 250 volt short duration EMP pulse, and take care. To that end, he has actually added a little plastic EMP shield to it so that you can't physically touch the high voltage parts unless you take it off. And so I didn't even know that you could order these kinds of high voltage isolation covers straight from DigiKey or Mauser, but apparently you can. The details are in the bill of materials here. But you know that you're going to want to take that off and poke around with it. So to that end, and to keep you from hurting yourself, he's made this lovely video where he pokes around in there at all the places you'd like to poke and shows you what voltages are going on where to save you from having to do it to yourself. The board is nicely isolated. It's in two parts. There's the high voltage part, and then there's the part with the Raspberry Pi Pico microcontroller and the two buttons on it. They're isolated from each other, so you're not going to get zapped by using it. Coming out the business end is an SMA connector, and you attach essentially a coil to that to do the EMP pulsing. Basically, the idea is you want kind of an antenna to transmit the pulse to the device under test. And all of this is easily done by, the average hacker. So if you want to experiment around with EMP style glitch injection, this looks like a really great setup, and it looks like something you could just go out and get made, and you'd be out of pocket 20 or 40 bucks, and you'd have something that's not quite as capable as the multi-$100 tools, but will probably get the job done for a lot of cases.
It was really interesting to see his talk during Remoticon. Unfortunately, we don't have that broken out yet.
That'll be coming out in the next few weeks as soon as we get that one processed. So stay tuned.
But in that, he kind of does the MacGyver approach and makes a similar sort of thing out of like a disposable camera, and shows how it works on the stream. So this is cool to see it, like that, the evolution of that idea, that you could do something cheaper, but not that cheap as to take apart a disposable camera and have to wire it all together and stuff. It was also really cool to see how this thing works in practice, which is really amazing. He kind of does a demo where it's like running through some kind of a script, and then you're hitting it with the high voltage pulses, and you can see where it flips a bit and drops out. It's really wild stuff. It's not maybe the kind of thing that the average hardware hacker would need, but like you were saying, if you ever wanted to experiment with it, the bar is much lower on this one, right? It's a lot easier to get into it and play around with it.
Get one of these boards made, try it out, and stay tuned for the Remoticon video.
Well, on the subject of lowering the barrier of entry for this kind of glitching attacks, we have a really interesting story about using a 555 timer to dump the firmware on a microcontroller. And that might not make any sense at first. What's happening here is that the microcontroller in question is set up so that you can't read the firmware back out of it. To get around that, Jarrett wants to voltage glitch the chip, which is to say you basically fiddle around with the power and get it right to the part where it would brown out, with the hope that you can get it to jump an instruction, specifically the instruction you don't want it to run. Using the 555 timer and jiggling around the power right about where he wants to read the firmware out, the hope is that you can get it to ignore the bit that is telling it not to read out the flash chip. The problem is that a 555 timer is way too slow under normal circumstances to make this realistic. So, he goes, if you read into the Hackaday IO page, he talks about having to get special high speed timers that only come in surface mount. So then he had his original was like a little breadboard. So he had to get the adapters to, put the SMD versions and drop them into his breadboard. By rapidly fluctuating the power fast enough, I think he talks about nanosecond fluctuations. You can, if you're very lucky, you can get it to not do the thing you're getting it to avoid. And in the end result, he was able to pull the firmware out by getting it to forget to run the that one command that was blocking him.
This won an honorable mention in the 555 contest. You shouldn't have done that with a 555 timer. And the reason is, the normal way you do this is with an FPGA or a really fast microcontroller, something that has really good control of timing, both in terms of the offset after you've powered up the chip under investigation, but then also to make this fast little brownout pulse that you need to do. And here what he's got is this classic circuit straight out of the data sheet for the pulse after a delay, right? And so you have two 555s, one gives you the delay, one gives you the pulse, and you can vary the length of one and the duty cycle of the other with potentiometers. And I'll be damned if he doesn't have two potentiometers sitting here. And so whereas you would normally write your FPGA to bracket all the times from this time to that time and all these different pulse durations, he's sitting there slowly turning these potentiometers and trying it again and turn the left pot and try it again and turn the left pot and try it again. Okay, now back to the beginning, turn the right pot a little bit. Now go through that sweep again. I just love the idea of kind of the analog hacking delay pulse voltage glitching. That made me laugh.
Like the safe cracking version of
totally
doing a voltage glitch. Yeah, you could imagine he's got his stethoscope up to the microcontroller, trying to listen in for the pins to click.
My first quick hack this week is AI Camera Knows It by Caleb. This is a sweet AI application. He's training it to recognize images of his dog squatting to know then eventually where the stuff is buried. And this is, if you told me 20 years ago that we would have computer vision that's capable of detecting when a dog is doing its duty, I would be like, yeah. And then you told me that that was a plausible project, I would have not believed it. Next up, ultra cheap PCB wrenches make perfect kit accessory. Ben Nix has a kit that he's put together that needs particular wrenches. His clever idea was to just get the PCB manufacturer to make them for him. This is probably not the wrench you want to use day in, day out, but for a project that's already got a PCB order made, he estimates he can get these added on for about 10 cents each, and they're super cute. And last up, 3board, short on keys, long on documentation. This is a project by Taylor Connor. I have to say, I would never use this, but he won me over with his fantastic documentation. The code is tested every which way from Sunday. It is beautifully clean. He's got a user's manual. He's got a simulation. All of this for a really horrible keyboard, which has only 3 keys, but yet can simulate an entire keyboard through a crazy combination of button presses. You really should go check it out to see how this is even possible. I guarantee you won't be typing on it, but I guarantee you'll love this project.
My first quick hack is Acid Damage Game Boy Restored. This is another awesome repair from Taylor. We've covered quite a few of his previous works. His thing is he gets old game systems and cartridges that any normal person would throw in the garbage. But actually, he probably gets them from the garbage. And he restores them. We're talking about missing chunks of the PCB. And, he rebuilds all the traces, and he does just a great job. It's one of those things I love to watch his videos. Would I do it? No. But through the beauty of YouTube, I can watch somebody else do this kind of PCB therapy. Next up, I have improve your front panels. And this is a problem I know I've personally run into in the past where, I've punched a few holes in a piece of metal and threw some switches in there, but getting text and graphics on it isn't always easy for the home gamer. So the idea here is you just print your text, your overlays, whatever you want to have on your regular printer, laminate it, cut out all the little details, and glue them on into place. It sounds kind of obvious. It's one of those things that in hindsight makes a lot of sense. And just looking at the results, it looks very professional, and I could definitely see myself having to buy a laminator for this technique. And finally, I have Serial Studio 1 year on. Serial Studio is kind of the evolution of the classic Arduino serial monitor. The idea is that your microcontroller sends out the data in a particular format, and you have this nice little visual dashboard to see gauges and lights and that kind of deal. We wrote about it a year ago. Chris Lott did a follow-up where he looked at some of the new features and some of the new capabilities, and it's just really cool to check in on some of these open source projects and see how they grow over time, especially when it's something that's so useful for our community.
And now it's time for our can't miss articles. These are long-form original content pieces written by our fantastic Hackaday writers. And first up, I'll pick fantastic Hackaday writer Tom Nardi's identifying malware by sniffing its EM signature. What is this? Is this like EMF day here on Hackaday?
Yeah, right?
We've talked about glitching. We're talking now about figuring out malware. Huh, weird. Things are in the air. Anyway, I love it here, Tom, the way you looked deep into this academic paper where they basically put a probe with an antenna straight up against the CPU from a Raspberry Pi. I love the way you pointed out that it's a 1 gigahertz, $10,000 picoscope, and that's kind of out of our realm. But I wonder how much of the 1 gigahertz resolution makes it through. Anyway, before I get too far ahead on the details, they listen in using an antenna to the chip and then try to use AI classification routines to tell if the chip is currently running malware or if it's currently running benign software. What's amazing to me is that they get this to work at all. I'm still totally surprised that the EM signature thrown off by a chip running software you want it to run looks different from software you don't want it to run. It really makes me want to replicate this myself as well, and we'll have to see. They do a lot of pre-filtering on the data coming in, and that's where I was wondering if maybe we could get away with a cheaper scope, you and I. But then they just chunk it in. It looks like they're doing kind of Fourier transforms on it, and they're doing frequency peaks over time. And so maybe what's going on here that the neural networks are picking up on is that I don't know, I have no idea whether the benign software would be doing more repetitive things or whether the malware would be doing more repetitive things, or whether it's just a difference in intensity. But they are able to tell different malwares from each other, even if they're in the same family. You should definitely download this paper. It's a PDF. It's available. And when you go through it, there are these things called confusion matrices, which are, if you think about, it has the same list of software on the x-axis as on the y-axis. And so along the diagonal there is when it detects the thing as the thing itself. And then everything off that diagonal is a false detection. It either thinks this one is that one or it thinks that one is this one. And so they're off diagonal. You should look at these in the paper. They get remarkably good results. So I'm weirdly skeptical, but then they get it done.
I was pleasantly surprised by this one. I'll say that.
Yeah.
I think, I mentioned it last week. We don't assign anybody anything, but we do throw ideas out there. And we had seen this one come in on the tip line, and, I had asked some of the other writers, anybody want to take this? And they said, no, this is nonsense. This is nonsense. This is some kind of, it can't possibly work. This is fake. This is whatever. I said, okay. And then, more people start sending it in, and I was like, all right, I guess I'll have to look at the nonsense. And I definitely expected it to be just one of those oh, there's grant money to be had. Let me grab some. And we've seen those papers, and we've kind of taken those apart in the past. But when I started looking into this, they really did their due diligence. I mean, they have a lot of information in here. All of the source code is open source and out there. Like I said in the beginning, it is all written for a very expensive oscilloscope, but there's got to be some middle ground there. There's got to be a cheaper scope that you could use, that's just what they had at the lab, right? But, everything's out there. They have a wiki that breaks it down literally step by step. If you have this thing, and I said in the article, we've temporarily misplaced ours. If you've seen it, we'll give you the address to send it back to. But like they do step by step every command that they ran, and that you could follow along with, and it really seems like it works. Now, works in an extremely narrow sense of the word, and I think that's the takeaway. It's how I kind of close it, and what I think a lot of like the the mainstreamy posts about it didn't really get is that in this exceptionally controlled situation, they were able to see what this Pi was running because they had already seen it run it. They've already recorded the signature and they could identify it again. In no way, shape, or form claim that they can then like take that trained model and go out and scan your home computer and see what virus is on there. And that's kind of the breathless reporting a lot of the other sites had used, and why it seemed so implausible, because that is a whole different thing. Nobody is insinuating that. Really cool paper. Like I said, it is available for free also, which is really cool. So you could read through the whole thing, and these are early days, but it's very tantalizing to see where this could go with some refinement and a wider array of devices tested with it. So my pick this week is Longer Range EVs Are on the Horizon by resident automotive expert Lewin Day. A common criticism of electric cars is that you have to plug them in and charge them, and as infrequently as you could do that, the better, right? Lewin says that right now you're looking at about 400 miles to a charge for your Teslas and that sort of stuff. But there are people who that's just not good enough. They want more and more. So he kind of does a rundown of where the big players are and where they hope to be in terms of range. And there's some pretty impressive numbers out there. A lot of it's still conceptual prototype stuff, but he talks about Mercedes pushing over 600 miles on a charge. Also, speeding up the charge too, 'cause that's a big part of it. It's great to run 600 miles on a charge, but if it takes a day to charge it, that's not going to do you any good. So there's, half the problem is charging quickly. The other one is holding a significant charge. Lewin also talks about one company who modified a Tesla Model S to get 752 miles, which is pretty impressive. And then he kind of wraps it up in the end, and this is, I should say, what really made me interested in the article. He says that the problem is that all these companies are making these gains, but it's all kind of black box behind the scenes stuff, and how are they doing it, and what are they doing, and the reality is we're all going to have electric cars at some point. You can argue about how long in the future, but I mean, we've already run the articles about the companies say, oh, we're done investing in combustion technology, and in 10 years and 5 years and 15 years, they're coming. For better or worse, they're coming.
I'm not at all scared of electric cars. I think it makes a ton of sense. I'm totally with Lewin on this one. He kind of starts off the article with, if cars are going 400 miles between charges, why do you need more? And I thought to myself, how often do I drive more than that far in a stint? And the answer is, of course, I do. If we go on vacation, sometimes we'll drive further than that. But we're doing that once a year, maybe twice a year. Is it worth designing the whole car around these extreme events? Or is it worth maybe sucking it up with a car that has 400-mile range on that one day that you want to go 600 miles and just like having an extra long lunch at the, gas station where you're putting more juice in the thing? So I don't know if I totally buy into the whole range thing. I guess there's the convenience of not having to charge it up every night or whatever, and that may matter, but I'm not putting in 400 miles a day. That's crazy talk. So I do kind of think the whole thing might be a little bit of a non-issue and, kind of a my numbers are bigger than your numbers pissing fight to some extent. There are kind of 3 cars he's talking about, and they're all taking really different approaches to getting more miles down. One of them, the Lucid Air, runs at 924 volts instead of kind of industry standard, which is around 400 volts. So it runs at twice as high a voltage, which means it gets to run at half the current. And if heating losses in the wires, I squared R losses, are proportional to current squared, anything you can do to lower the current helps you out a lot. And so if you up the voltage but lower the current, the car will just by that run more efficiently. And I think that's probably some percent of the trick that this company Lucid is getting here. Their cars run about 20% further per kilowatt hour than a Tesla does. And some of this is an extremely streamlined car, but some other parts of it may actually be this super high voltage. And then you look at like Mercedes, which has gone all the way into streamlining, even further into streamlining, but then also lightened the car up and, reduced all of the flim-flam. And this is a concept car. To be fair, this one is not a real production car, and it's a little bit underpowered, and it's ridiculously streamlined. It looks like it's from the future. All of this, but they managed to push the same battery that both the Tesla and the Lucid car have, the same number of kilowatt hours, to something like an extra 50% efficiency. So they go yet again further. And it's really interesting to see how these companies can push this stuff. And then there's the one you mentioned, this one company, which just basically puts an ultra heavy duty battery into a Tesla and sees how far they can go. So they've got like the double size battery, and you won't be surprised that they get almost double the mileage when they do this, right? But that shows yet another kind of margin that these companies can work on if they really do care about going further in the car. Like, there's the battery technology. There's the efficiency of running at a higher voltage system. There's making it more aerodynamic. There's reducing the power of the motors so that you can use higher efficiency motors. There's like all these different ways that they can game this. I'm not sure this is the right goal to be putting all this engineering effort toward, but it's really neat to see, and it's really neat to see how kind of the increasing energy density and stuff like that plays out. I might want to see something like longer battery life be one of the concerns before I want to go an extra 100 miles in a day, but at the same time, I understand the range fear. When you're 400 miles from home, you're definitely going to wish you had a tank full of gas that'll get you that 400 back. That wraps it up for this week's Hackaday podcast. If you'd like to get in touch with us, you can email us, editor@hackaday.com. You can check out all the links at hackaday.com/podcast. And until next week,
Keep on hacking.
is that how this starts? How many mistakes can he make in one sentence? For the love of God. Just get tough, Elliot.
All right.
Oh, I want to... Oh, yeah, go ahead.
No, what you got?
Nah, we'll just do it. I'll just do it.
Okay, it'll be a surprise then.
And I forgot to write down who did this. I'm a bad person. Speaking of Star Trek props. Oh, Star Wars, you said. Whatever, same thing.
Say it. Pew, pew, pew.
Oh, that's pretty good, actually. I think we might be done. I'm going to have to bleep this out.